G'day! In this series of videos, we are combining Psychopy and Python programming to do the line bisection task. And if you recall in the previous videos, if you've seen the previous videos, the line bisection task can be used to probe and push around visual-spatial attention. We're looking at an attentive task. And one of the things that I've glossed over a little bit in the previous videos is the timing of the stimuli. You'll notice that our stimuli, when we present the stimuli, I'll just run this task again, it's a bisected line, but we present it very quickly. And so we're trying to use all the resources, the visual resources and the cognitive resources to pay attention to that stimulus. It's purposeful. So the reason why we present it, let me start again. There's a reason why we do it so very quickly. We need the task to be almost at the limit of our abilities. And so if I hit F again, you'll see we fixate for a second, we orientate our gaze, we get the attention onto that area, and then we quickly present that stimulus. Now we know, for instance, in this case, that every stimulus that we present is going to be a bisected line, okay? i.e. the left side and the right side of the line are going to be the same length. But the part of the bisected line task that we have is, well, some of them, in fact, what is it going to be? 37.5%, was that 15 out of 40 trials? They're actually going to be off-center. Left side's going to be longer or shorter. Let me just get the cue out of the way. So if we go back up to the top of our program where we pulled apart that Kim paper, which is what we're basing this experiment off, we have created our fixation. So this is created. So that's done, and the duration is done. Our stimulus, we have for the most part got the elements, the fundamentals there. What we haven't done is given ourselves the ability to do the various lengths of the line. And the other thing, we have done the vertical, we have done the thickness, and we haven't given ourselves the ability to push the line to the left or to the right. But we'll do that in an upcoming video. What we haven't done, and what I want to do in this video, is to create, we need to do this now. And so remember in the Kim paper, what they did was they basically presented a very long horizontal line and they extended the vertical line up to the edge, and that was their mask. And we can do that, that's not an issue, but that's boring. I've done a lot of psychophysics experiments for colleagues, and they're wonderfully boring experiments to do. So what I would like to do is to give a little bit of visual interest into the experiment, just to, to try and maintain just a general sense of alertness in my subjects. So my mask is not going to be a simple extended cross or extended rectangle. What I'm going to do is I'm going to create a random assortment of circles. Now I'm going to call it a bubble mask. I don't know if that exists in the literature, but hey, look, we can come up with our own names. I don't know why I did that, but anyway. In order to do this, I'm not quite sure how to do this, and so what we'll do together is I'll take you through how I pull apart this sort of problem, and then read the documentation and pull together all the elements of what it is that I'm expecting. And so here you can have a look in the mind, in my sort of problem solving and figuring out just how the heck do I do this, okay? So in my mind, what am I thinking? I'm thinking, okay, I want some circles randomly located in the area of the screen where the stimulus was being presented. And I want them to be of roughly the same color composition. So I'm thinking black, white, and gray. And the other thing is I'm thinking of different sizes. And so therefore it's going to be visually stimulating, but also masking and sort of irrelevant to the task. So what we're going to do here is we're going to run off our line task file. You'll see that this is our main program file that we created right in the first video. We're going to run in the sandbox now, because what we're going to do is we're going to try some ideas out. And once we get an idea that works, we'll then transfer it over into our line bisection task. So here we can do whatever we want, delete whatever we want, muck around as much as we want here. And it's not going to affect our main program. So let's just make sure that things are working. So print OK. And I'll just put OK sandbox just to make sure that we're running in the sandbox. Now this file is located in the same folder as the main task. So in our command prompt or in our terminal, we're actually in the correct folder. So if I now type Python 3 line_sandbox, okay, it should now be playing this sandbox program. So yeah, okay sandbox. Now again, import os.system. I just want to clear the output of the command prompt again. And so we'll do clearless if os.name equals nt. Else we want to pass the clear function. Now if you haven't seen the previous videos, you don't know what it is that we're doing here, but essentially in this one line of code, we are able to tell the command prompt or the output to clear its what's being presented, and we can do that on a Mac, a Linux, or a Windows machine. Okay, so we're playing in the sandbox now. So now from Psychopy, if you don't want to write this out yourself, you can just cut and paste from your line bisection task. Import core event. Do we need event? No, we don't need event. We need visual. Core and visual will do, and so we will create a window. Win0 equals visual.window. The size will be 1920 by 1080. What screen do we want it on? That's screen 0, that's screen 1. Do we have any calibration that we need to do? Again, no. So the monitor that we're using is just the test monitor. If you do have a calibrated monitor, test monster, monitor, monitor, okay, then obviously you would call up that file. Monitor equals test monitor. The position, well, the position argument is irrelevant because we're running a full screen here. Full screen equals false. Allow GUI. So do we want to see the toolbar at the top? Yeah, this is okay. For our actual experiment, we'll turn that to false. We don't want to see that. The color, we'll set the color to be white. So red, green, and blue, all at 100%. And the units that we want is going to be pixels. We're converting everything to pixels here. Okay, and so then if I go win0.flip, core.wait, say 2 seconds, and then remember we tidy up everything at the end, and so win0.close. And so hopefully what we should see here, there's no such thing as psycho high, so PSYC, so that's a spelling mistake from Andrew's perspex. So what we should see here is a full screen blank canvas window. We've gone through this in the previous videos. That should last for about 2 seconds and then close down. So this is good. This is the canvas upon which we want to create our circle or our bubble mask. Well, let's have a look now at the documentation from Psychopy and see whether or not there's a stimulus or a stimuli, okay, that basically is something like random dots or random circles or anything like that. Let's have a look. So we've got window, so we've used this to create our window. Commonly used images. We're not showing an image, we're not showing text yet. We will in the future to tell our stupid subjects what to do. Text box, shape stim. Okay, well we can show circles here. Let's keep going down. Images and patterns. We're not going to do any gables or gratings or anything like that, or any noise. Oh, here we go, dot stim. To show and control movements of dots. Well, circles are dots, aren't they really? So let's click on that. So visual.stim, so let's put this on. So visual dot, let's call this big black circle, circ equals, so I'm now just copying what's here. So visual.stim, I'll start that on the next line. And so this has to be written onto a window in memory, and we've got the window in memory already. That's going to be win0, so that's the window object that we've created. So dear Psychopy, please put the following onto the window 0. Now the units that we want are pixels, so pix. The n dots, what does that mean? So let's have a look now. Dot size, signal dots, noise dots, elements, field position, direct speed, premise, n dots, number of dots to present in the field. Okay, so this is a fairly old computer. So the more dots that you present, probably the more memory resources that you're going to have. So let's just have, say, 50 dots. Okay. Now remember, this stimulus here, dot stim, is actually for moving dots. We're going to leave our dots as static, and so therefore if you start to have moving stimuli, random orientation, or it's no coherence in their movement, they're just all random, then if you have 10,000 dots, it's just going to bog down your memory. Whereas if you have one dot, it's not going to be visually distracting. And so you have to find that interplay between numbers of dots and how often they're moving and what speed and direction. We don't have to worry about that too much because our velocity is going to be 0. Okay, so let's have a look. Coherence. So coherence is, are they moving in the same direction, essentially, I believe. Let's have a look here. Coherence is proportion of dots which are coherent. Oh, what a wonderful explanation. Okay, I think coherence is, okay, if you have perfect coherence, every dot is moving in the same direction. Whereas our coherence is negligible because we don't need coherence. So let's just put it in there anyway. Coherence equals 0. I don't think we need that. Field pos. So whereabouts is the field? So we're going to create a field of stimuli, field of circles. And then is it going to be in the middle? Is it going to be left? Is it going to be right? Whereabouts is it that we're playing? And so we'll just put it in the middle. So 0, 0. Okay, what else do we have? Field size. Field size. Well, I think this from memory can take only a certain number of shapes. So it's either going to be a square field, or it's going to be a circular field, or it's going to be a cross field. Okay. So that's the next argument, I think. Field shape. So field shape, we're going to make it a square shape. Okay. And so the field size is, we're going to make it as wide as the x-axis of our monitor. So in our case, we've got 1920 pixels in the x-axis, and so therefore if we have it in the y-axis at 1920, yes, we're going to be basically overdrawing our canvas, but I don't think we're going to be pushing our resources to the limit here. So if I go field size 1920 by 1920, then everything should be fine. Okay, play around with this if you want. You know, make the field size really small and see what happens if you change the shape. See what you get out of it. Okay, dot size. So dot size. Let's just make these dots say 20. I don't know how big or how small this will be. We'll see what we get. Okay, play around with it. Dot size. Dot life. 3 direction equals 0. Speed. Okay, here we go. Speed, which is French for speed. Speed is 0. We don't want them flying around. We just want them static. Color equals. So what do we call them? We call them big black circs. So color will be -1, -1, -1. Okay, opacity is 1, contrast 1, depth 1. So that should all be fine. Signal dots, we don't need any of these other things here. We'll see what we get out of this, okay? I have no idea, but we'll draw this. Remember, we've got our window in memory. We're going to draw our stimulus onto the window, and then we have to flip our window onto the screen. So big black circ dot draw, okay? Win0 dot flip. Let's see what we get. I don't think I need that coherence. You see here, in our previous video, we set the logging of Psychopy to critical. And I said, hey, that's because this is an old computer. I don't need to know frame timings or anything like that. So here, this is actually an output of one of Psychopy's sort of checks, frame timing checks. Is your graphics card set to sync or vertical blank? Are you running other processes on your computer? Yes, I am. It's because it couldn't measure a consistent frame rate. So every time that it presents something onto the screen, okay, is going to log that time and then say, hey, look, is it pretty precise, or are we starting to drop frames, okay? And then it says, hey, the timing of the last frame was 20.7 milliseconds, and so it was 1 out of 48 frames, okay? So I don't want any of this frame timing nonsense. Well, it's actually important, but not for our stuff. We'll leave it on there, but if you want to get rid of it, you do console.logging set to level. Okay, I've saved that. We're still going to run sandbox. Okay, coherence equals 0. So what have I done wrong? Coherence equals 0 says positional argument follows a keyword argument. So positional argument follows a coherent. Let's get rid of, well, hang on. Let's just see what coherence takes first. Coherence equals 0.5. What have I done wrong? Let's just get rid of it. We don't need it. Did I spell field pos wrong? N dots equals 50. Oh, okay. It's because I haven't got the equals there. Okay, so that coherence, I think I was a bit hasty to get rid of it, but I don't think I need it anyway. So let's see what we get out of it. Make sure you put your equal signs in there, guys and girls. What do we get? There we go. We get some black circles. They're not very big, are they? Let's make them a little bit bigger. Let's make them, say, 80 pixels, not 800 pixels. We'll Command S that. And what we'll do is we will put, instead of 50 dots, let's just put 5 dots and see if we can count. Hey, look, there's 5 dots here. Some of those dots might be overdrawn outside the boundaries of the canvas, remember, because it's 1920 by 2, 3, 4, and I think one of them's probably overdrawn there. Okay, so that's fine. 50 dots there. Great. So this may not look like much at the moment, but we are starting to build up a bigger stimulus, masking stimulus here. We've got just the very bare necessities here. So dot size 80, so that's the big black circles. Now, Command C, Command V. Because what we want to do now is we want to have big grey circles. I think hopefully you can follow what we're doing here. We're going to create and draw big black circles. Okay, and they're randomly positioned. And then every time that we call this visual.stim, it's going to randomize the set of dots that we create now. And the color's going to be different. So the color's going to be gray. So let's make these, say, 0, 0, 0. So remember, if all 3 red, green, and blue channels are the same magnitude, it's going to be a gray color. So big gray circ dot draw. Now, have a look here. We draw the big black circles first, and then we draw the big grey circles next. What actually happens is, in memory, is that if there is a black circle and then a grey circle is drawn over the top or at that same location, it's going to override it. And so now you're going to see the grey circles appear in front of the black circles. The drawing order, wow, that's really hard to say. The drawing order matters in some of your experiments. So you can see here, the grey circle is on top of the black circle. Okay, so now we've got the big grey circles, and so now let's have some big, let's make some white circles. Now you might say to yourself, hey, well, the background is white, Andrew. Why are you making white circles? Well, remember, the white circles are going to be drawn on top of the grey circles and on top of the black circles. And so therefore it's just going to be more visually interesting, more visually appearing, because you'll actually see the cutout of where the white is. Let's see if we can see that. Yeah, so you see here you've got this sort of weird shape there. What we can do is we can, instead of making that 111, we'll make that sort of 0.75. Okay, so it's pretty white, but not fully white. Okay, we'll just see how that looks. I'm just seeing how this looks. You know, I have no idea what it's going to look like until I've run the program. Okay, let's have a look here. Yeah, that's looking pretty good, really, isn't it? So that's a pretty good start, but they're all the same size. So what we can do now, okay, we've got the big black, grey, and white. Let's make some small ones now. Let's make some small black circles. And instead of being 50 dots, we'll say make 100 dots. And their dot size, we'll make them say, we'll put them down to 20, okay? 20 pixels, and we'll make, say, 100 of these, and 100. Okay, big grey. So this will be small grey circles. Oh, let's go to the front here. Small white circles. And so therefore, if we now go small black circles dot draw, okay, small white circle dot draw, and then small grey circle dot draw. Okay, so here, very quickly, we've built up a masking stimulus with some big circles and some small circles, different color shades of grey. So here we go, look at that. That's looking pretty cool. It's still not quite doing it for me. I think we might need to... I might put in another grey circle here. It's a big grey, so I might put in some... I'll put in some dark grey. And the dark grey, the colour will be... so that's minus 0.4. Again, I don't know how this is going to look, but... excuse me. Minus 0.4. I don't know how this is going to look, but we'll just see how it is. Big dark grey circle. So if we go yeah, that's looking a little bit better. But we also want the black. We also want a little bit more black as well, I think. I've got no reason why I'm saying that. It's just my Jackson Pollock coming through. So we'll make it, say, 80 dots. We'll just give some more black dots. Now they're big and they're also small. Maybe they're too big and too small as well. So, or sorry, maybe the small are too small. We'll make this, say, 30. We'll see what we get. Yeah, okay, so that's looking relatively... yeah, that's looking okay. All right, so if we have a look here, okay, I'm just going to do a while true, just so we can see this a little bit better. Okay, when 0.flip. We can get rid of that, and then we'll go key equals event dot weight keys, max weight equals key list equals q if q in key. Now, if you haven't seen the previous videos, this is probably not going to make much sense to you. So watch the previous videos, and then you'll see what it is that I'm doing here. Basically, very quickly, is I'm going to present the stimulus for as long as ever, was for 99999 seconds, okay? And it's going to wait until I hit the letter Q, okay, in this key list. And if I do hit the letter Q, it's then going to break out and close things down, okay? And so I will need a vent here, okay, because I want to basically look at the stimulus for as long as I want to look at it for. And so it's going to do this until I hit the Q. I've done something wrong. event.wait keys equals q. Has no attribute wait keys. Maybe it's wait key. Let's have a look at what it is. So the spelling is really important. Wait, capital K-E-Y-S. Okay, so I didn't put a capital K there. Okay, so that's me being an idiot. Because the next thing that we need to think about here is what happened there, guys. What do you reckon happened? Oh, hit the Q. It's because when I hit the Q button, okay, it win0.flipped. Okay, so what we need to do is, because remember, we drew nothing to that stimulus, so we don't need anything in there. Okay. So this should win0.flip and then just do its thing forever and ever else. That actually looks pretty cool to me. But if you notice here, we've actually got the masking stimulus throughout the whole screen. But we don't want to do the whole screen because remember, we want to just mask that region of the monitor where the stimulus was played. We don't want to overwhelm our subject by getting them to look everywhere and then focus in on that fixation cross. This is not what we want to do. So how would we go about basically blanking, I guess you could say, or covering up? There we go. We want to cover up the top bit of the monitor, so the top half and the bottom half of the monitor. How can we do that? That's looking really cute, actually. Actually, I might change the small grays. I'll just change the color of the small gray. So I hit Q. So the small grays, they're at 0, 0, 0. Let's make them 0.2. Okay, just because I had the big and the, see how the we've got some large grey circles at 0 as well. Just every single shape was a different colour, or every different colour is a different shape. Okay, size. Sorry, not shape, size. But the point, or the problem still stands, and that problem being, well, how is it that I can cover up or mask the top half of the frame and the bottom half of the frame? This one doesn't look as good, but it should still do its job as a masker. So if we think about the different sort of shapes that we're trying to mask, we essentially want to mask a bottom rectangle and a top rectangle, okay? But we don't want those rectangles, so we want to, if we think about it, where's my monitor? So we want to block the top bit and the bottom bit, and then leave a strip in the middle untouched. Okay, so how do we do that? Well, we know, for instance, that Psychopy can generate for us a rectangle to show rectangles. And so if we now go here, we've drawn all of our stimuli, okay, but now what we want is we'll say upper white rect equals, so now we're just going to read off here, visual.rect. The window is going to be the same window as we draw everything else on. The drawing order is going to be important, but anyway. The width, we want a full screen. So the full screen, 1920, because we want to mask basically the whole bottom strip. Okay, and the height, well, we're going to have to play around with this a little bit, but let's just start at, say, well, what's the height of the whole screen? It's going to be 1080 pixels. And we want to say top, say 100 pixels. We want to keep it about 100 pixels. So let's say it's going to be about 400 pixels. We'll figure it out at some point. Now, the units are going to be pixels again, so that's fine, pixels. But now what we need to do is we need to have the fill color, my friend, fill color. We want this to be white, okay, so that's going to be 111 in the red, green, and the blue. And the line color, because remember, the rectangle has a fill, so the color of the middle bit, and then the color of the bounding line, that's going to be white as well. So we'll go 111. If you needed to debug the position of this, set your line color to black, and then you'll see the outline and go, I've screwed up there, or I need to do something. And then make sure you set that back to being white once you go into production or you're finished testing this. The other thing that we need is The position. Okay, the position of this rectangle. This is what we're going to need to play around with. So the position takes 2 arguments. Okay, so tuple. Okay, it's going to take an x position and a y position. Well, we want the x position to be basically 0. We want it to start at 0, 0. Okay, but we want the y position. Now, is this the upper or the lower? So this is the upper white rectangle. So we want this to start up at some y value. Let's start it at, let's say 500 pixels. Let's just see what we get. Okay, so plus 500 pixels. And so the last thing we want to draw is the upper white rect dot draw. And so hopefully if we've done this correctly, we have a look here. Line color, what have I done incorrectly here? Oh, again, you need your equals. There's your answer. If we've done this correctly, we should see hopefully the top part of our stimulus, of our screen, being masked out. And so there you go. You can see, hey, we've got no stimuli here in the top. Okay, that's great. So that's a start, but we need it to be bigger. I don't know why I said bigger like that, but anyway. So let's put the position at, say, 200. Let's just see what happens if we just set the position to 200. Should be 400 high, position of 200. So it should appear 200 up, and it should be 400 in height. And so therefore, there you go. That's 200 up, 400 in height. So we've brought it down a little bit. Okay, and so if we now make the position, say, 200, but we make the height now, say, 300. Oh, let's just make the height 500. 500, so 250, position 250. Yep, okay. So it should start at 200. The height should be should be 500. And so that should blank out most of the top. And it does blank out most of the top, so this is great. Okay, and so if we set the position now to 250 and we make the height now, say 600. I'm just slowly shifting it up and making it a bit higher. You know, just trial and error it to see what you get. Okay, well there we go. We've blocked out pretty much most of the top there. Okay, that's great. And so now if we make the position 250, but now we make that, say, 600, we put the position to, say, 300. It's quite windy here today. Okay, there we go. That's not looking too bad. Okay, so I might set the position up a little bit taller. So set the position to, say, 350, and I'm just going to now make the lower rectangle, which is going to be pretty much exactly the same thing, but just with a inverse y position. So I'm going to make it negative 3, 4, 5, 6, 7, 8, bonk, like that. We'll make this minus 350, and we'll say this is the lower white rectangle. So we'll draw that last lower white rect dot draw. We'll see what we get. So hopefully what we've done here is we've masked the top, we've masked the bottom. There should be a strip in the middle that's about 100 pixels high. And that's about what we're seeing here. Okay. And so therefore that's looking pretty good, but it's not very well populated with the circles. Okay, so what I think we need to do now is we'll just up the numbers of dots, you know, by 100 in each. Oops, that was by 2 too many there. Okay, we need to fill it in now. Now they're going to be random in every single time that they're drawn into the memory and then they're flipped. Okay, so this is looking a whole lot better. There's a lot of interest there for me in that. Okay, so here we go. We have now just created our masking stimulus. We took it step by step, day by day. And so therefore we have some big black dot stim circles. We've got 180 big black dots in a 1920 by 1920 field, and they're 80 pixels in diameter. They're not moving at all, which is really good to see. We've created some grey circles, some dark grey circles, some white circles, and then we've created a whole bunch of small circles as well. What we then did is we then created a box, a white box, and then we drew it onto the screen up the top because we basically wanted to stop the top from showing that masking stimulus. And then we created another rectangle which blocked off the bottom, and then we drew all that together. So we did all that in the sandbox. And so now what we can do is we can go back to our main task here, and we can create another function, and we'll call this masker stim. We don't need to pass it any arguments, okay? And then here we are creating our masker stimulus. How do we get the stuff across from our sandbox? Well, we just cut and paste it. Let's go big black circles right through to rectangular draw, and we'll go Control C, and then we will put that into here. Tab across, make sure you're at the right tab. Control V. And so now when we call masker stim, okay, masker stim, okay, we draw that and we clear the screen. We don't want to clear the screen anymore. We want to mask. We want to mask the stimulus. Okay, remember that's only going to draw it into memory. Okay, so draw into memory. And then we need to flip the masker from memory onto the screen. So this should hopefully work. This is our stimuli with our upper and lower white rectangles. It's all being drawn into memory now, and then it's not going to do anything until the next time we call that win.flip. Now, the brilliant thing is that every time we run a next trial, okay, it's going to call this masker stim, and it's going to randomize the dot placement. So every single trial, it's not going to be fixed. The dots are going to be in a new position, and that's also going to be a little bit interesting. And basically, just keep them entertained, although not, it's not relevant to the stimulus. Let's go back to our Python 3. Have I saved that? Yes, the line task.py doesn't have that blue circle there. So if I now go line task.py and I run this, I don't know what I did just then. I think I saved it. Oh no. We should see basically our experiment. So fixation cross there, stimulus, and then the masker. Brilliant. Now, what I'm looking for is to see whether or not the width of the masker stimulus here, from here to here, is greater than where the stimulus was, the fixation stimulus was presented, okay? I need it to be slightly bigger, because otherwise, you're not perfectly masking the whole stimulus. So I'm just going to hit J, mask stimulus, okay, F, mask stimulus, okay? And it looks like every single time we do this, the masker is slightly different. So there we go. We are now masking the stimulus. Great. What do you reckon? It's pretty cool. It looks okay to me. I've had it looking better before, but anyway, there we go. Hit Q, get out of that. So now we've created our masking stimulus. Brilliant. This is excellent work. We now have a single trial. There we go. We've got it all up and running. Single trial from start to finish with some timing. Okay, the timing should be okay for any government job. But, again, if we want better timing, we'll get better timing later on. Let's now start to make some decisions, okay, on what to do when the subject responds. Can we start recording the subject's responses better? Okay, so we are looking for these keys, okay? We're looking for F, J, or Q, and we've already decided what to do if the Q key is pressed. Well, let's decide what to do if the F key is pressed. So if F in key, Now remember, every time that we come to this key, okay, we are clearing the previous event. So we should only ever get one event in our key list. So if f in key, what did we say right at the start when we created this experiment? F is for left side. So we'll cut that, copy that, and we'll say now, okay, F is for left side, which means there's a lot of comments here. You probably don't need this for yourself. You know, subject thought the left side was longer or shorter, okay, depending on what they've been asked to do. Okay, and then we'll say print left pressed. Okay, so again, if you're doing this in JavaScript, that would be like a console.log just to say, hey, look, we've got some key presses here. So if, what was it, J in key, okay, subject thought the right side was longer or shorter, depending on the task, okay, the right side was. And then we'll print here, right pressed. Okay. Brilliant. So now when we hit the J and the J or the F key, we should be able to log in our command prompt that what was pressed. Okay, so I'm going to press F, J, and then we'll just hit Q. And so we should see left pressed, right pressed, and see that's what we've got here. So great. We've now got some way of pulling back into our program what was pressed on the by our subject, which is good. What we can do is we're at the part of the program now where we can split into one of two ways. We've got to do both of them now, but we eventually. But I'm in two minds as to whether or not we go through the data logging and the subject response logging, or we go through the stimulus, changing the transected, bisected line stuff by putting in some more arguments into the function. What I think we might do at this stage is we've got the basic program up and running for a 36-degree bisected line. I think we might finish this video by just recording the subject's responses and doing just a very general control over how many trials the subject will do. Because remember, the subject does 4 blocks of 40 trials. Okay, so we will need to do this 40 trials. Okay, because at the moment, let me just close this down. Okay, so that's not in our way anymore. Because remember, this is our main program loop, and it's just going to continue on and on and on and on and on and on and on until the Q button is pressed. But that's not what we want. What we want is to only run for the numbers of trials that we need to run for. And in our case, it's going to be 40 trials. Because remember, that's how long each block was. Each block was 40 trials. So what we can actually do is we can actually change this while loop. We can say for I in range 0 to number of trials. Okay, I've done a lot of things here. This I is an iterator or a counter. It starts at the number 0, and then every time we run into that loop and everything is satisfied, it will increment by 1. And we're basically saying, okay, we want to count up essentially for between these values. We're going to start at 0, and we're going to go up to the number of trials. And so we need to basically say, okay, dear program, please run for the following numbers of trials. So you see how we put all up here, we haven't declared any variables. So now one of the variables would be number of trials, and we'll just set this to 10 at the start. Eventually we'll go up to 40, but if we did 40, then it takes us a very long time to debug our program. So if we just run 10, or hang on, we'll just run 5, okay, then we'll get through it a lot quicker. And so when we think about it, we're going to run into this main program loop and it's going to say, okay, we're going to start this loop, and it says, okay, we initialize our counter to 0 and we say, okay, is the number 0 within these two values? Is 0 between 0 and the number of trials? We've set the number of trials to 5, so we'll just remind ourselves here. Remind us, trials, this is no trials is 5. And so the first time this is called or instantiated, yes, 0 is between 0 and number of trials. Now remember, in Python, the lower bound is included, but the upper bound is not. Okay, so 0 is in the range 0 to number of trials, and so since that's true, it will then complete this experiment. And then once it comes back up to the top, so if it's hit F or J, it will then come back up to the top, and then it increments this I. And so now it's gone from 0 to 1, and then it checks, hey, is this between 0 and the number of trials? Remember, that's number 5. Well, yes, it is. 1 is between 0 and 5. And so therefore, it will run the program again. And then it will run through again and again and again until it gets to the number 5. And then it says, okay, is 5 between 0 and the number of trials? No. Remember, in Python, it includes the lower bound, but it does not include the upper bound. And so therefore, once I reaches 5, this is no longer true. And so therefore, it will then go back to the parent or the primary indentation data, which is we're going to close everything up and basically print OK, program and window closed. But here, this is really good because we've got two things that we've got access to now. We've got access now to the trial number. So what we can do is we can say, we can print current trial is, and we just put into that the iterator. Oh, look at me with my bad spelling, okay? And so we know now for the first trial, or the 0th trial, which is the first trial, the subject pressed this. For the second trial, the subject pressed something. Okay, we can actually now link together the trial number and the subject's response. Because when we save our data, and this is one thing we're going to do in the next video, once we save our data, we are going to have a spreadsheet or some format of data which has the trial number, the stimulus size, the bisected or left side or right side or whatever the task is, and the subject's response, left or right. Did they get it correct or incorrect? And so here we're using a for loop, and that's given us access to the iterator. So let's see what happens when we do it. Okay, so we run this program again. Fixation cross, unexpected indent. What have I done here? At line 174, fixation cross. Okay, so you need to make sure that all your indentations are correct. So I've highlighted all that. I hit Shift Tab. That brings all of the highlighted bits back one. Let's see if I've made a mistake again. I hope I haven't. Okay, so this is trial number 0, or the first trial. Okay, there it is. I push the F. We're now on to trial number 2. I push F. We're now on to trial number 3. I then push J. We're on to trial number 4. I hit J. Trial number 5, I hit F. And so therefore, there we go. We've now broken out of that. And so we know that for the first trial, left was pressed. Second trial, left was pressed. Third trial, right was pressed. Fourth trial, right was pressed. Fifth trial, left was pressed. And then it basically said, hey, look, we've done our trials. Thanks for coming. Yeah, let's break out of this. So if you're new to Python programming and you're not sort of up to speed with 0th counting, it does take a little bit of time to go, hang on, it starts from 0. So if you count to 10, it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Whereas in school, you probably started at 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So just make sure that you're aware that Python is 0th counting, and that when we start a loop, a for loop, it will start at 0, and that it does include the lower bound in this range, but does not include the upper bound. And you can figure that out yourself by counting how many trials. Yes, it stopped at current trial number 4, okay? However, we've done 1, 2, 3, 4, 5 trials. And that's how many trials we set out to do. I've been gabbing on now for 50 minutes. In this video, we have created the masking stimulus, and we've also created our main program loop. This is probably close to the final program loop that we'll need to do. There's a little bit more that we have to do, but it's not a great leap of imagination. And we've also started to get the keyboard input and start to think about, well, how are we going to save these responses so we can do offline analysis? And well, now we've got the trial number, we've got what the subject responded, and so therefore we can start to look at some pretty we can start to look at saving this data and putting it into a format that we can then use to analyze later on. Okay, I'll leave this video here. Good luck, and I'll hopefully see you in the next video. All right, catch you later.